All right, today's video is just to show you a library that I created for the ESP32, which is intended to make LED control asynchronous and very easy to set up with very little, very few lines of code needed within the main program. And the library consists of two files, an ledcontrol.c file and an ledcontrol.h file. ledcontrol.h sets up some enums. So you have a thing like a behavior, LED behavior, which is either on or off for solid lighting. And then you have blinking behavior, fast blinking, slow blinking, and a cyclical behavior, which is to cycle through the colors. And what I'm using is a 4-pin LED, which has 3 colors. So three pins for each of the, 1 pin for each of the colors, and then a ground pin. And the other thing that is defined in the enum is the LED color, the red, green, or blue. And then there's some variables to hold the behavior and the color, and then a bunch of functions which are to control things like setting the or getting the blink intervals, which is the time between blinks, setting the brightness of the LEDs, and then setting up the actual pin numbers. In the ledcontrol.c file, we are setting up default values for brightness for the 3 colors, and then the blink intervals, which is in milliseconds. That's the time between being on and off. And then the cycle interval, which is the time between cycling from each of the colors. And then it implements the functions themselves, which are defined in the header file. The actual core behavior is in this function here, which will run as a task. I'll show you that in a second. Control LEDs, which is just a switch statement on the behaviors and the colors, and then based upon the colors that you've turned on or set to blink, it will give you the behaviors that you've set up in your actual main file. So going over to this file, this is the test file called ledtest.c. This would be your main file. And an ESP32 environment, it has an app main as the entry point into your program. And what you do is you set up the LEDs, and that's a function here which sets the pin numbers, sets the brightness, and then initialize the LEDs. And then you create a task, which is this lightweight task, which uses this library, calling this control LEDs function. And then you set up your main task, which is whatever you want your program to do that's going to make use of LED behaviors during runtime. So it's running currently, and in the terminal window here, you can see it's going through its various behaviors. And then in the lower right, you can see one of these 4-pin LEDs actually implementing the various behaviors, or blinking slowly or turning on, and blinking fast, and going through the different colors that are available within that 4-pin 3-color LED. So the task itself, which would be whatever your program needs to do in order to get the behaviors that you want, all you need to do is tell it what behavior you desire and which color you want. So for example, I set up LED color red. I tell it behavior on, and when it reaches this point in the code, it will turn the red LED on. Switching behaviors or colors, I can switch that to green with the behavior on, or blue, or I can do something like blink. So I set the LED to red, tell it to blink, and that task will pick up on these variable settings and implement that behavior asynchronously based upon that task that's running, looking for those variable settings. So in this app main, or in this test program, I've set up the LEDs. I've created the task that controls the behaviors of the LEDs, and then I run my main task, which in this case is just showing, here it is down here, showing how the various LED behaviors can be set up and controlled. So in essence, your code can do whatever it needs, and all you need to do is set up these 2 variables the way you want it, and the LEDs will behave the way you want it. So you don't have to deal with LED timing or anything else anymore. within your main code. Just set up the variables and it will behave that way. So that's the nature of this library. I will, below this video, post a link to my GitHub so you can access the code itself. All right, thank you for watching.